testing and commissioning hot water systems. So key objectives for this part of the session, I want you all to be able to describe each step of the commissioning process and identify the tools used, particularly for performance testing, but also for testing the pipework as well, hydraulic pressure tester. I want you all to be able to describe how to test plastic and rigid pipework, and you need to make the documents on Moodle to help you with this, and describe the steps you should take before draining a hot water system for maintenance. The process for commissioning is as follows. Firstly, you carry out a visual inspection of the installation, then test the system, flush the system, then performance test the system before handing it over to the customer. We're going to look at each of these steps in a little bit more detail now. Firstly, our visual checks. As soon as you finish the installation, you should take a step back and have a look. Just check that everything is the way it should be. The pipes are vertical, on plumb. They've got the correct clips at the correct intervals. There's no pipes that are sagging. And we've got no open ends. Everything's tightened or soldered the way that it should be. After you've done your visual checks, you can then carry out a soundness test. Essentially, what soundness testing is, it's checking that the system isn't going to leak. Normally filling it full of water and pumping in a bit extra pressure to check its sound. The process of testing is described in BSc in 806. There's also a description in the Water Regulations Guide. And there's a mention of testing as well in BS 8558. So all of these are worth being aware of as potential sources for information on testing pipework. There's two key test procedures we need to be aware of. One for rigid pipe, for example, any metallic pipe, really copper, steel, stainless steel, etc. Or plastic pipe, which could be a polybutylene, cross-bonded polyethylene, medium density polyethylene. Any of these plastic pipes should be tested with a plastic pipe test. There's documents on Moodle which explain these processes in a lot of detail, and we're just going to look at some general principles that will apply to these tests beforehand. Firstly, testing is all relative to the working pressure. Normally you're testing at 1.5 times the working pressure, at least initially. And we need to be able to work out what the working pressure will be. If you have an open vented system, you need to know the difference in height between the water level in the system and the lowest pipe in the system. And basically multiply that height in meters by 0.1. And the reason that we do this is each meter's head of pressure gives you roughly 0.1 of a bar. And that doesn't matter about the shape of the system, doesn't matter if you've got pipes going here, there and everywhere. It's all to do with the vertical height and the vertical height only. And that's what will affect the static pressure of the water. Okay. So a good example would be if you've got 3 meters head of pressure, the working pressure you times 3 by 0.3, that gives you an answer of 0.3 of a bar of head of pressure. 5 meters head of pressure, 0.5 of a bar, etc, etc. Really easy calculation to do. You then need to sort of multiply whatever your answer is by 1.5 to work out what your test pressure will be, because that's what you're doing here is you're working out your working pressure, times it by 1.5. That gives you your test pressure, because we always times 1.5. Pressure test at 1.5 times the working pressure. Another thing worth noting, if you're testing open vented hot water systems, make sure that you turn off the cold feed, cap off the open vent pipe before you test, because otherwise you'll just be pumping water out of the overflow in the system essentially. Obviously make sure you take the cap off after you've finished the test. Testing rigid pipe. It's always good practice to fill the system up with water half an hour before you test, check for leaks. Also allows the water to reach an ambient temperature, we call it temperature, a period of time for temperature stabilisation. And then once the temperature is stabilised and you've done your walk round to check for leaks, you then pump it up to 1.5 times the working pressure and leave it for 1 hour. There should be no visible leaks and no pressure loss during that time. And as we've talked about before, it's very, very easy to work out 1.5 times the working pressure. Essentially, you just take half of whatever the working pressure is, you add it to the actual working pressure, and that gives you your test pressure. So, for example, if we had the working pressure of 0.4 of a bar, or 4 meters head of pressure, so we take 0.4 of a bar, we take half of that, which would be 0.2 of a bar, add it to 0.4, gives us a total of 0.6 of a bar. Another example here, if I had the working pressure of 0.6, so that's 100% of the working pressure, we take half of that, which is 0.3 of a bar, add the 0.3 to the 0.6, gives us a test pressure of 0.9 of a bar. Very, very easy calculation to do. For systems containing plastics, there's 2 different tests, test A and test B. And like I've said before, there's a flowchart on Moodle which describes each of those. So the next step after pressure testing, after soundness testing, is flushing and disinfecting. Normally we wouldn't need to disinfect hot water systems. That would just be done in commercial or industrial premises. But the purpose of flushing is to remove debris. You normally do a cold flush first, and then once you've actually got the system heated up, you'd give it one last hot flush normally to remove any extra flux that would have dissolved as the water heats up and flows through the pipework. It will start to dissolve some of the flux which will be inside of the pipe. It dissolves much more quickly with hot water, so it's worth giving the system a bit of a flush through with hot water before you do the handover, so the customer doesn't get sort of foamy flux. Fluxy foamy water is what I was trying to say when the first time they open the tap. It's also worth remembering you always do a hot flush when commissioning heating systems as well. Performance testing. So once we've completed our flushing, give the system a final fill, check the installation works really, check for correct operation, so check the terminal outlets, the taps open correctly, float valves are opening and closing correctly. It's worth also checking that the thermostats switch the system on and switch the system off at the correct times. The programmers also do the same. So the programmers would turn the system on at the correct times, turn off at the correct times. The cylinder stat would turn off when the temperature drops and sort of turn off when it reaches a set temperature. And actually you can kind of check these without it getting up to necessarily its full temperature by adjusting the temperature on the thermostat. You'd sort of hear it click to go on. You'll be able to sort of feel that the heating is going on, the pump's going on, the boiler's started. And you'll also be able to feel when it goes off and hear when it's going off as well. You know, just go to where the pump is and sort of feel the pipe and listen essentially. A couple of things maybe worth noting. Hot water systems, the water should run at 50 degrees within 1 minute of us opening the tap. And this is actually all about preventing Legionella. And we check this with a thermometer, obviously. Thermometer is what we use for checking temperature. Check flow rates with a weir cup, sometimes called the flow cup, this thing here. And we check pressure with a pressure gauge, like this thing just here. It's finishing the job. Always sort of when you're doing what we call the handover, verbally explain the controls to the customer and make sure that you give them all of the manufacturer's information. You can find extra information on commissioning in the installation instructions for the appliance that's been installed. And they might sometimes have a benchmark commissioning checklist, particularly things like boilers. And that should be given to the customer when the job is complete. We'd also use the installation instructions for maintenance and servicing. So yeah, it's a useful thing to make sure that the customer has to help people who may come in the future. And if you do need to switch the water off or the electricity off to work on any components, let the person who lives in the house know before you switch it off or you drain it down. Obviously, before you drain down, make sure you isolate the water and also turn off the heat. Yeah, after you've drained it, make sure the system is completely empty. You can sometimes end up with, if there's a vacuum in the system, for example, the air can't get in, particularly in sealed systems. You could end up with a vacuum, and then you cut into the pipe, and next thing you know, you've got a load of sort of water shooting out that was kind of trapped in the pipework before due to negative pressure. So a good way to sort of try and prevent that: open up all the taps, start up the stairs, open up the taps as you're draining, and it just allows the air in so the system can drain more readily. Also be aware of any kind of dips in the pipework, which could contain a moderate amount of water still as well. You know, it's not something that's going to come up in the test, but just it's something worth being aware of. Okay, so now it's time for your task.